as I'm looking at this problem, first thing that I'm thinking of, this is going to have to do with the distance between 2 points, the distance between several points. Thinking back to my high school geometry class, that we had this sort of theorem in geometry. Here, I'm just going to draw the line flat on the paper, and I don't know just by looking at these points which one might be between the other two, but if they're on a straight line, I'll use X, Y, and Z for the points, because I don't know by looking at the points how I would orient D, E, F. So let me go with X, Y, Z. If they're on a straight line, then I would know this, that the distance from X to Y plus the distance from Y to Z will equal the distance from X to Z. So that is from a standard geometry class. So I probably need to start finding some distances here. I think to kind of give me some insight as to what point might be in the middle, I think I'm going to go ahead and plot these points, which is probably not necessary for this problem, but I'm going to plot the points, and that might kind of help me out to see what distances I might need to find. So I'm going to draw my axes here. I'll do the way they have them labeled in the book. X kind of coming out towards you, Y, and then Z. And then to plot these points, I'll do, let's see, D. Let's put in with dotted lines the negative X, the negative portion of the X-axis, the negative portion of the Y-axis, the negative portion of the Z-axis. And then so for D, 0 units on X, -5 units on Y, and then 5 units on Z. So I'm going to draw a line parallel to Z. 1, 2, 3, 4, 5. Go up 5 units on that line. Here's point D. And then I will plot E. So for E, I'll come out 1 unit on X. Then I'll go -2 units on Y. And then up 4 units on Z. So that would be point E. And F, I'll come 3 units on X, 4 units on Y. So I draw parallel to Y, and I'm going to mark my 4 units actually on that little dotted line I put, and then up 2 units on Z. So here's F, and it looks to me, now sketching it is not really the way to determine if they're on the same line. From the sketch, I'm thinking it looks like they could be, and it looks like if they are, that E is the one in the middle. So I'm not 100% positive on that, but that's kind of my hint here that this is what I want to try for this problem. So for the solution, I'm going to find the distance from D to E. I'll find the distance from E to F, and I'll find the distance from D to F. And then I'll see if they satisfy this equation, they are then on the same line. So I have to go with the distance formula. The distance formula in 3 space, if I do D to E, it's the square root. We'll subtract the x values, 1 minus 0, that quantity squared, plus subtract the y values, -2 minus -5, that quantity squared, plus then 4 minus 5, that quantity squared. So this is the square root of, let's see, 1 squared plus, okay, -2 plus 5, that's going to give me 3 squared, and then I have at the back there -1 squared. So this is the square root of 1 plus 9 plus 1, that's the square root of 11. And then let's go with the distance from E to F. So that's going to be the square root. So I'm going to do 3 minus 1, square it, plus 4 minus -2, that quantity squared, plus 2 minus 4, that quantity squared. So I have 3 minus 1 is 2, so 2 squared, and then 4 minus -2 is 6 squared. Okay, 2 minus 4, that's -2, so that's -2 squared for that part there. This will give me the square root of 4 plus 36 plus 4, and that will be the square root of 44. Okay, now I'm thinking this, I'm kind of thinking ahead a little bit. I'm looking at this and I'm thinking, what am I going to do with this square root of 11 plus, well, now that I've seen the square root of 44, I can rest a little bit easier, because the square root of 44, 44 is 4 times 11. So then I can say the square root of 4 is 2. So this is 2 times the square root of 11. So if I need to do some addition, at least I have like radicals at this point. Now let's find the distance from D to F. The distance from D to F is the square root. So I will go with the points, the coordinates from F minus D. So open parentheses, 3 minus 0, that quantity squared, plus then 4 minus -5, that quantity squared, and then plus the z's, subtract the z's, 2 minus 5, that quantity squared. So this is the square root of 3 squared plus, well, 4 plus 5, that's 9, 9 squared, plus -3 squared, so that's the square root of 9 plus 81 plus 9. Let's see, that'll be 81 plus 18, that's going to be square root of 99. And the square root of 99, I can write it as the square root of 9 times 11. So the square root of 9 is 3. So this is 3 times the square root of 11. So now, does it fit this little equation? This is a theorem from geometry. 3 points are collinear if their distances, the one in the middle, if the distance from one end point to that point plus from that point to the next one is the same as the distance from the 2 end points. So they're collinear if the distance from D to E plus the distance from E to F is the distance from D to F. Well, the distance from D to E was the square root of 11. The distance from E to F was 2 times the square root of 11. Does that equal 3 times the square root of 11? And I probably should put a little question mark above that equal sign because I'm questioning whether or not those are equal. Are they equal?
Yes.
Yes, because these are like radicals. You can add these together. So that is 3 times the square root of 11 does equal 3 times the square root of 11. Yes, they are collinear.